Let's talk about the effects of Ang2, angiotensin 2 on the blood pressure. And as I already mentioned before, Ang2 has very important rapid pressure effects, which means they are very important for the short-term regulation of blood pressure. So things that our blood pressure can adapt very quickly. And then we have also the slow pressure effects, and they are more important for the long-term regulation of our blood pressure. So let's start talking about how does Ang2 affect our blood pressure very quickly. And here we can also distinguish between direct effects and indirect effects. As it relates for the direct effect, it's mainly just AT1-mediated vasoconstriction. So Ang2 acts on the AT1 receptor on the vascular smooth muscle cells. That's a GQ-coupled receptor, and then calcium is going to get in, and you're going to trigger vasoconstriction. Now, it does also a lot of other things that are more indirectly, but also happen fairly quickly. So let's talk about a couple of these effects. Number one, this Ang2 receptor, the AT1, is a G protein coupled receptor, AT1, also sits presynaptically. So if that's a neuron, which, let's say, a noradrenergic neuron, which has norepinephrine and releases that, and this acts on this effector organ. What happens is that when Ang2 binds to the AT1 receptor, presynaptic AT1 receptor, well, it's a GQ coupled receptor, so you're going to have more calcium, and calcium triggers exocytosis, so you're going to release more norepinephrine. So you can already see that Ang2 also gets us more norepinephrine out, and norepinephrine is also a very potent vasoconstrictor because it acts directly on the blood vessels on the alpha-1 receptor. So that's how it also increases blood pressure, just by kicking out more norepinephrine via this presynaptic AT1 receptor. So I've just written this down here. So Ang2 acts on this AT1 receptor presynaptically. We're going to get more norepinephrine. And then besides this presynaptic AT1 receptors, there are other effects how Ang2 can increase blood pressure. Number one, there are also AT1 receptors in the adrenal medulla, so in the adrenal gland. And we know, what does the adrenal gland make? Epinephrine. So if you stimulate them, AT1, GQ coupled, more calcium, calcium releases also epinephrine. So we're going to get more epinephrine, and that can increase blood pressure. And then there seems to be also a central effect. So Ang2 can act centrally to just increase sympathetic tone to the blood vessels. So here are several effects that Ang2 does indirectly to act as a pressor, and these are all considered rapid pressor effects because they happen fairly quickly. What else can Ang2 do? It also is very important for the long-term regulation of blood pressure, and that is a kidney effect. That has all to do with functions, effects of Ang2 in the kidney, because in the end, Ang2 leads to increased sodium and water retention. And the moment we have more water retention, we have a higher stroke volume, and in the end, this also will lead to an increase in blood pressure. And how does it work? Well, this can happen either directly. There are AT1 receptors in the proximal tubule, which leads to increased sodium reabsorption. And then also indirectly via aldosterone. This is this hormone that also leads to increased sodium and water retention. So it holds on sodium. And aldosterone also comes from the adrenal gland, from the cortex, and there's also AT1 receptors, so once there's Ang2, it can also release, via this GQ-coupled receptor, more aldosterone, and aldosterone also acts in the kidney to hold on to sodium, so we're going to have more sodium and water retention. So these are all effects, either direct effects in the kidney or indirectly via aldosterone, that in the end help to regulate our blood pressure on the long run. And this all takes a while, because these are things that are happening in the kidney, affect our blood volume, so they are considered slow pressure effects.